All right, so today we're going to graph cube root functions by transformations, and I'm going to show you some other methods too. So you're going to learn how to graph a cube root function. So here's our parent function. Okay, I'm going to start down here with 0. So the cube root of 0 is 0. Okay. If I put in 1, the cube root of 1 is 1. If I put in 2, the cube root of 2 is going to be 1.2599. So it's not going to be pretty to graph. If I put in the cube root of 4, that's going to give me 1.5874. So that's not going to be pretty. So what we want to look for is perfect cubes. So 8 is a perfect cube, and the cube root of 8 is going to be 2. And then the next perfect cube is 27, and the cube root of 27 is going to be 3. Okay. Unlike square roots, a cube root of a negative number is going to be a negative number. It's going to be cube root of -1 is going to be -1. So if you think about that, -1 cubed is -1 times -1 times -1, which will give us -1. So that's why we have negative cube roots. So then the cube root of -8 is going to be -2. So let's graph those points that we can graph. So -8, -2, -1, -1. We can graph the other points. 0, 1, 2 would be 1.2, so it's going to be right about there. 4 is a little more than 1.5, and then 8 is 2. So we have a function that's got this little hook in it kind of thing here that looks like this. I tried to draw it straight, but sometimes it's hard. And it's just going to go off. Let's try that again. All right, so my domain and range are both going to be all real numbers. Okay, it's going to go forever and ever, so it's going to go to -infinity to +infinity, which looks obvious because the arrows are going that way. The range is still going to be -infinity to infinity. It's just going to take a lot longer to get bigger and bigger and bigger. Because after 27, the next perfect square is 64 with 4. So it's going to take a long time to get bigger and bigger and bigger. So how do we graph? Well, we graph with transformations, just like we did with all of our other graphs. So A flips us over the x-axis, so we multiply the y values. B flips us over the y-axis, and it's that reciprocal 1 over b. H translates horizontal, K translates vertical. So let's just look at a few examples. Again, the nice thing is if you get stuck, you can always plug things in. So normally we start at 0, 0, right? And this is how I look at graphing it. If I start at 0, 0, and then I'm going to go up 1 and over 1, down 1 and over 1 this way, and then it looks like this. So I'm going to translate the points of 0, 0, 1, 1, 8, 2, and then -1, -1, and -8, -2. Okay. So if I'm going to translate them, remember that this -4, we multiply to the y values because we're flipping it over the x-axis. And then the 3, we subtract from the x values. So this, if this helps you, would be -3 and 0. If we subtract here, we would be -2 and -4. So 1 minus 3 is -2. 8 minus 3 is 5. And 2 times -4 is -8. Okay, -1 minus 3 is -4. And then -1 times -4 is 4. -8 times, or minus 3 is -11. And -4 times -2 is +8. So those are our points. And it's another way to do the translations. So -3, 0 would be here. -2, -4 would be here. Okay, and our parent function, it would be here. Okay, 8, 2 would be 5, -8. Then -1, -1 would be -4 and 4. And then -11 and 8 would be over here. So our graph is going to look like this. And a little smoother, of course. Just hard to draw sometimes. All right. Notice that we had moved our parent function. So now in this case, we're going to take those points again, and I'm just going to start with -8, -2, -1, -1, 0, 0, 1, 1, and 8 and 2. So we're not going to do anything to the x value. We're going to subtract 1 from the y. That's what this is, our k. And then we're going to multiply it by 2. So all of our x values remain the same. Our y values, we subtract 1 and multiply by 2. So -2 minus 1 is -3 times 2 is -6. -1 minus 1 is -2 times 2 is -4. 0 minus 1 is -1 times 2 is -2. Okay. 1 minus 1 is 0 times 2 is 0. 2 minus 1 is 1 times 2 is 2. So here are our points. -8, -6, -1, -4, 0, -2, 1, 0, and 8, 2. Okay. So what we've done is we have taken our parent function. I'm just going to graph it on there real quick so that you can see. Okay. We've made it twice as high. Okay, but the distance from here to here is 2 instead of 1. And we have just moved it down 2 places, or 1 place. Okay. Questions? All right. With this one, the only transformation is the negative and the 1/8. So what I might do with that is just make an X and Y table. I think sometimes inside is a little confusing. So if I wanted this to be 0, okay, if I put in 0, I get negative cube root of 1/8 times 0, which is 0. So that Y value is 0. Okay, if I put in 1, it's going to give me a fraction. So what I want is it's just easier to graph and more precise with our whole number. So if I put in 8, I get negative cube root of 1/8 times 8, and that's 1, and the cube root of 1 is 1, so it's going to be then negative 1. So 0, negative 1. Okay. If I put in negative 8, okay, that's just going to become positive 1. Okay, so I have 0, 0. I have 8, negative 1. And I've got 8, 8, negative 1. And I've got 8, positive 1. So we've shrunk it by half. Okay, and if you notice, half is the cube root of 1/8, right? So we shrunk it by half. Right. So now when we go to graph this, let's factor out our negative 2. So we get y equals the cube root of negative 2x minus 4 plus 2. Okay. So again, I'm going to move up 2, and then I'm going to move to the right 4. So I'm going to go over 2 and up to 4. Sorry, over 4 and up to 2. Okay. And with this negative 2, it's going to flip over the y-axis. Okay. So now I might pick things that are going to give me perfect cubes. Okay. If I pick 0, if I let x be 0, I'm going to get 3 cube root of negative 2 times negative 4 plus 2, which is going to give me the cube root of 8 plus 2, or 2 plus 2, which is 4. So I'm going to go over to 0 and up to 4. Okay, and because it's symmetric, I can go down 4, or down 2 and over 4 from there. And that will give me my graph. So I'm going to get that little snake curvy thingy that looks like that. So we looked at how to graph a cube root function kind of by plugging points in, kind of by transformations. Just kind of a combination of those to help you understand that a little bit better. Have a math-tastic day.